Welcome back, AutoCAD for Technician students. This video here is going to show you basics, or we're going to discuss some basic architectural design standards, I guess you can call them. Now, this is extremely basic architectural design. So basically, it's stuff you need to know to create floor plans of your own. So if you're making a floor plan of a shop floor, you need to be aware of certain things. So if we're looking at this drawing here, let's zoom in a little bit. Zoom extends. Zoom in E. So this drawing here is a basic drawing of a residential garage. So we have a utility room there, office, garage. I showed you how to annotate things in previous learning plans. So we have dimensions here. One thing I want to point out is this little 6-inch dimension here. So the 6-inch dimension is actually defining this area between this line and this line. Now for most residential structures, wall thickness is 6 inches on the exterior walls. Now if we look at this one, this is actually measuring an interior wall. So this wall here is 4 inches thick. Now that's very important to remember. Okay, because a lot of times people go and try and draw a floor plan for a garage they want to build, or they're drawing a floor plan of a shop with offices in it or something, and they don't account for wall thicknesses. Okay, if we were to just draw a line here, around here, our room would essentially be 4 inches bigger than it actually is, which 4 inches, it doesn't sound like a lot when you're talking about a large building, but it's not accurate. Your room size is not accurate. So you have to account for wall thicknesses when you're drawing a building. So if we look at our drawing here, our overall length is 50 feet long, our width is 30 feet wide. And but remember, we lose 6 inches for the wall here and here. So our actual usable interior length is 49 feet. And actual usable interior width is 29 feet. So it's just something for you to be aware of. Now, when we're talking about things about doors, doors come in all sorts of shapes and sizes. I just put some standard 32-inch interior doors in here. 2 feet, 8 inches is 32 inches. And for an exterior door, I have a 3-foot door. Okay? And you have to think about things like, when this door opens, where is it going to go? So when we open this door, we can't put this door right in the corner here because it'll slam against this wall. Okay, so things like that, basic architectural design. And now, talking about garage door widths. So these are actual 9-foot garage doors. It's not a standard size. Most standard size doors you can purchase directly from your home improvement stores like Menards or Home Depot will run 8-foot widths. Now in my experience, I've built a few garages. And if you have any larger vehicles, say larger pickup trucks, 3/4-ton pickup trucks with larger fold-out mirrors or something like that, or larger vans, you're going to want a 9-foot door. Okay, it may be hard to squeeze those vehicles into an 8-foot door. Okay, so everything I've built, I put 9-foot doors in. Keep it easy. Keep your cars not scratched. Okay, again, just some reference ideas. Okay, a lot of this information is available via Google. You can Google basic architectural design or how to design a garage, things like that. Okay, you don't have to rely on me. Now, another thing we need to talk about is roofs. So on a house, the roof structure is, a standard roof structure is based off a 12-inch system. And you'll hear like a 412 or a 512, 612 pitch on a roof. Those are standard terms when talking about roofs. What that means is a roof, if you have a 412 pitch, you'll have 4 inches of rise for every 12 inches of run. So that means if we look at this building is 30 feet wide. If we cut that in half, the peak should go right up the middle. So 15 feet is your peak. So in 15 feet, you have 15 feet and you multiply that times 4, and that should give you your rise. So you should have 4 inches of rise for every 12 inches of run. Okay? So every 12 inches, it's going to rise 4 inches. So if we take 15 feet, let's get the calculator out here. 15 times 4. We're going to have 60 inches of rise. Where that comes into play is on your roof here. That's how you draw the height here. So I'm going to dimension this right now on my dimension layer, just to see how high this is. So 6 foot 3 inches. Wonder, I'll bet you I went with a 5/12 pitch on this. Let's try this. Sorry, I had a problem using the calculator there. Yes. So if we take 5/12 pitch, meaning 5 inches rise for every 12 inches of run, so it would be 15 feet times 5 comes up to 75 inches. 75 inches divided by 12 is 6.25. So 0.25 comes out to 0.25 feet, I guess you could say, comes out to 3 inches. Okay, a quarter of a foot is 3 inches. So I used a 5/12 pitch when designing this garage on mine. Now, many of you may have looked at like modular homes or pre-built homes like your Wassa homes or Stratford homes, or the ones that come in 2 sections on a truck. Most of those homes, unless you special order them, come with a 4/12 pitch. And for Wisconsin, it's a fine pitch. Remember, now there's a whole lot more involved with architectural design besides just getting the dimensions right. Architectural design involves calculating snow load and what type of roof pitch you should have based on your snow load. So what is suitable here in Wisconsin may not be suitable for, let's say, the Rocky Mountains in Colorado or something like that. You might have to have a steeper roof pitch because it's so much more snow. Okay, so just think of it as lower the roof pitch, the more effect the weight of snow has on that roof itself. Okay, so I guess that's the basics for calculating out your roof pitches, designing a floor plan, and including interior walls, door sizes. So if you have any more questions, please contact your instructor. Thank you. Happy drawing.